Hi everyone, and thank you for joining us for a webinar today on a 3D modeling showcase in Vectorworks Fundamentals. My name is Laura Bucci, and I'm a marketing specialist here at Vectorworks. Let's review a few quick housekeeping items. First, this webinar is being recorded, and the on-demand version will be emailed to everyone, as well as posted to Vectorworks University. If you have any questions throughout the presentation, please feel free to enter them in the questions box, which is located right in your control panel. We will save time at the end for live Q&A. And last, please take a moment at the end of the webinar to fill out our survey so we know what you'd like to see in the future. Now I'd like to introduce our presenters for today, 4 Vectorworks Fundamentals experts. Joining us is Luis Ruiz, Senior Architect Product Specialist, Sam Griffith, Process and Analytics Project Manager, Ryan Butler, Architect Product Specialist, and Tony Krzyzewski, Senior Landscape Product Specialist. Luis, Sam, Ryan, and Tony will showcase some of the many versatile tools and workflows of the software to design and showcase their projects. They will show you the power of solid, subdivision, NURBS modeling, surface arrays, rendering and lighting techniques, and much more. Today's presentation will cover the following learning objectives. You will learn how to identify the various 3D modeling technologies and techniques in Vectorworks Fundamentals, recognize the extensive file import and export options available in Fundamentals, including avenues to 3D printing and other fabrication, discuss the process of modeling your work and creating its associated 2D drawings, and describe the range of rendering styles available to depict and present your project. So without further ado, let's get started.
Hello. Happy to be part of this webinar. Let's get right to it. I want you to learn the benefits of one of the most sophisticated 3D tools in Vectorworks Fundamentals called Subdivision. So, for you to get a clear idea of the objects you can model with this powerful tool, I selected a few from my past projects. In some cases, shapes like this one, a pavilion of some sort, like a rib cage or an outdoor tunnel. I also have a few smaller samples like this side table made of multiple stacking materials. Over here we have a simple sofa, but please take a closer look to the armrest, the cushions, and the pillows. Cage modeling, also known as subdivision modeling, was initially developed for the animation and entertainment industry. This technology was licensed from Pixar Studios, and since 2016, we've been able to provide our users with the power of 3D exploration. Subdivision modeling is all about the cage. And if you ask me what this tool feels like, I would say it's closer to playing with clay. Now, where do we start? By learning about primitive shapes. These are simple starting objects. Some of them have volume, and the rest are just flat surfaces. Our subdivision tool lives on our 3D modeling toolset. By double-clicking on its icon, we can create our first shape. We'll start with a simple sphere. While selected, check out the info palette. There are different values for iteration. A higher number makes the sphere smoother, and a lower number reduces its surfaces count. The next thing I want you to learn is that many objects can be transformed. While an object is selected, go to the Modify top menu, down to Convert, and locate Convert to Subdivision. Here you will be given the option to select the iteration density, but you'll have the option to change it later in case you need it. Now let me select this corrugated solid. We'll find the Convert to Subdivision menu. Now let's get closer and I'll show you what editing and rescaling a subdivision feels like. I'll select the transform and rescale mode, and I'll resize its top by pulling from the 3D dragger. There are other surfaces available, but I'm going to skip to this face mask. I believe this is a mesh. One of the benefits of this transformation is that we can make the face features ultra smooth. Great for creating content. Now let's take a closer look at the tool. When selecting the subdivision icon from the modeling toolset, you'll have a series of modes on the top bar. To start, you'll be concentrated on just a few modes: the transform mode, the crease, the extrude, and the split mode. You'll need these three on the right: translate and rotate, scale, and reposition. And depending on the face of the cage, these two alignment modes. Here's the best way to practice using the subdivision tool. I would recommend creating all of the primitives and align them like this. One by one, select each of the primitives and start the transformation. Every time you make a change, slide a duplicate and keep going with more and more explorations. Start with a sphere. Make sure you include all of the modes, and in no time, you'll find yourself feeling comfortable manipulating new shapes. Depending on your type of projects, you'll find that some of these modes will become your favorites. For me, creating furniture content requires a lot of splitting edges and creating wrinkles. Okay, by now, I guess you want to see some action. So let's pretend we want to win a commission for an installation art. And here's a sketch of the artwork I have in mind. I'll start a project with a simple block, an extruded rectangle. Then I'll select it and convert it to a subdivision object. If I leave it as iteration 0, I'll keep the same shape. But I know I needed a 3, and you'll see why. I know I need to flatten the end faces. I'll use a crease mode, and I'll click on these faces to make them flat. One here, another one here, and here. For my next step, I'll use a split mode. I'll start touching this edge and type 50 for the percentage. I can also find the middle snap points to divide each face in half, a few vertically and just a few times horizontally. Next, I'll add a few more splits near the previous ones. No need for precision. I'm just eyeballing the distance. Just give me a few seconds. Still adding a few more. And this is enough. Oops, I forgot one more. Okay, and done. Now I'll go back and use my first mode, transform. I'll select this quadrant over here. While I press Shift on my keyboard, I'll add more selections. Now I'll change the alignment and I'll grab this arrow and pull them all just about here and here. Yes, that looks good. It feels very bubbly. I won't do the rest. This is fine. I guess you get the idea. Now let me move on to the final shape. I saved it for you in advance. If I show you the cage, you will see I move these control points closer to the top, and over here I pinch them all closer together. This one is what I originally had in mind. I also tried to experiment with wrinkles, something that looks very bulky, like bulky waves. This last one is a combination of waves and puffy boxes, but I could still use it if I change the base just a little. Don't know yet. Okay, let's move on and I'll show you how we can morph this subdivision object even further. As you see, I have a series of extrudes surrounding the blob. I'll select them both and from the model menu, I'll select the intersect solid operation. Done. The next move will be to add a texture. Just a matter of selecting the object, and from the info palette under the render tab, right here is where we can assign and control the textures and its mapping. I made another option over here, and this reminds me I need to show you the benefits of modeling history. If we get inside this object, you'll see I have a subtraction of two objects. If I move the concentric circles to one side and then hit the exit button, we'll see how easy it is to make changes. Back here, I have one of my favorites. You can tell it is our subdivision waves intersecting with vertical solids. I find it to be a very cool effect. Since we can create presentation renderings inside this same program, here's a view to our first proposal. Perhaps the material could be some type of fabric, but we can always change it and show more options like changing the material to be some type of reflecting plastic or maybe thin foil paper. If we want to take it to the next level, we could add LED lights between the gaps. I think the overall effect is very creative. I think it's going to be effective. But what about the other options we created? We could propose the one with concentric circles. I can see the reflection on the wood floor could be visually something very interesting. Here's a last one. The waving pattern and lights, I think so far is my favorite. I could even see the LED lights on the back changing colors at different cycles. And finally, I wanted to show you that animations can also be created inside fundamentals. This is another great way to explain a project. Well, I certainly enjoy giving you ideas of what subdivision is all about, but I will leave you in good hands with a talented colleague. Screen is all yours, my friend.
Hello, my name is Sam. I'm nowhere near as much of an expert as the other presenters here today, so instead of showing you 3D modeling in Vectorworks, I'm going to show you how I've used some of the tools and fundamentals to help me with my own businesses. First off, I'm going to show you how Vectorworks helped me make these concrete pieces using volumetric calculations. When I go to actually manufacture these pieces, I need to figure out how much silicone I need for the molds, and then how much concrete I need to fill them with. So I first need to make a positive of the end design. Next, I need to create a shell around that positive so I have a container to put the mold into. I do that by extruding a rectangle slightly bigger than the original positive, and then using the shell tool to hollow that out a little bit. Next, I'm going to move my design into the middle of the shell that we created. I'm going to center it, and then I'm going to align the bottom of my design with the top of the recessed portion of this shape. As you can see, I had to make a tweak here just so I could get the depth a little bit better for the end mold shape. Once I have that done, I add the two solids together, and voila, I have my final positive. Now, in order to create the negative shape for our final mold, I'm going to create a rectangle within our positive piece. Essentially, I just want to extrude this and then line things up so that it fills the negative space of the shell that we created. I'll then select both shapes and then subtract, making sure that I keep the new shape that we have created with that extrusion. Finally, I have my mold. I want to see how much silicone I'm actually going to need for this, so I'm going to go to Model Volumetric Properties. By default, this is showing me in cubic feet, and I don't really feel like doing math, so I'm going to go in and change my properties so that I can see cubic inches instead. Now that I've changed things over to cubic inches, I can go back into my volumetric properties and figure out exactly how much silicone I'm going to need. This makes it much easier for me to calculate and purchase my silicone. Ultimately, I can do the same thing for the actual concrete pieces themselves and figure out how much concrete I need to mix before I make each piece. This has been extremely helpful, saving me time and money during my manufacturing process. Now, one problem I have is that when I go to use a CNC router or a laser machine or a water jet, I need a 2D file in order to actually start working in it, and I often create my original files fully in 3D. So I want to share with you today a tip that's really helped me with some of the designs that I've made in order to actually get some things built. Taking a look at this little aquarium light that I had made, I originally designed this using all solid modeling, because that's all I'm really good at. Some of the pieces were 3D printed, and then some were laser cut acrylic. So in order to prep the laser cut pieces, I needed to just get a 2D file ready. Rather than tracing things out again or going back through my file to get to the original 2D shape, you can actually just go to Modify, Convert, and Convert to Lines. And this will give you a nice 2D shape that you can then export out as a DWG or whatever you need and use it for your file. And as you can see, when I went to export this, I chose to just export the selected object so that I only had that portion. And then open it up in Illustrator, for example, and you can see my 2D shape. The same process applied to a plastic injection molder machine that I was making. Again, I entirely designed this in 3D using solid modeling. Not going to bore you with the details there. But when I went to begin making this, I had a friend who has a water jet and needed these as a DWG. So I had to take each of these panels and convert them into lines so that I could then get a 2D representation for all of these panels, nest them together, and then throw them on the water jet machine. It saved me a ton of time and energy. So there you have it, just a few ways that Vectorworks Fundamentals has helped me to design and manufacture tons of unique objects. Thank you so much.
Hi everyone, my name is Ryan, and I'll be showing you how to model a light fixture in Vectorworks Fundamentals just by using simple 3D tools and utilizing classes and textures. Most of the tools we'll be looking at today are in the 3D modeling toolset. Let's get right into it. First, I decided to model the light bulb itself. I drew a circle and then created a class that has a glass texture within its attributes, so that when I set the circle to that class, it automatically takes on that glass texture when it's extruded. After I pulled up that extrusion, I used the fillet edge tool to soften the bottom edge of this extrusion a bit. A ½ inch looks good to me. To make the shape hollow, the shell solid tool is the way to do it. Select the tool and set the desired thickness, then select the face of the shape you want to have an open edge. To model the filament, it's another extruded circle, but this time the extrusion has its own filament class. In that class, a glow texture is used. More on that later. Now let's model the socket of the light fixture. Draw a couple of circles and extrude them, then apply a plastic texture to them. Something about these textures, they are attribute textures, meaning you can have a color set for the fill and the texture will apply with that color. So the socket has a plastic texture with a black fill that I set in the attributes palette. Next up, I drew another circle, but this time I used the tapered extrude command, which is in the model tab at the top of the window. From there, I set the height and the angle that I want, and I joined all these socket pieces together by using the add solids command in the contextual menu. For the cord, it's another extrusion. Alright, great. Now the light bulb, the socket, and the cord are done. From here, I created a symbol with this geometry to keep stored as a resource, which lives in the resource manager. Okay, let's move on to other pieces. To make the horizontal pieces, I drew more circles and clipped circular holes in the middle of them using the clip tool. Then I extruded that so that a donut shape is shown. The horizontal pieces have their own class with a wood texture applied to it as well. For the vertical pieces, I started with 2D line work to draw the desired shape. I drew a polyline and then offset that with the close open curve setting enabled. With the reshape tool, I can convert one of the vertices to a Bezier curve to soften it a bit. And to soften even further, the fillet tool was used to round each corner. Cool, so now the 2D shape is ready to be extruded. Once that happens, it's assigned a wood texture via class settings, but a face override is used to show a different texture on the edges to show some variation. This vertical piece is then made into a symbol as well. Last steps in the process. I place the vertical piece in position with the light bulb, socket, and horizontal pieces. Then I drew a circle from the middle of the whole fixture. I then used the Duplicate Along Path command in the Edit tab at the top of the screen and used the circle as a path and the vertical piece as the object to be duplicated. There are settings you can play with as well, like Center Object on Path, Tangent to Path, and Keep Original Orientation. You can preview the duplication as well. The final result is this. The whole light fixture is a hybrid symbol, so it has 2D line work as well as 3D geometry. Right before I created the symbol, I drew some 2D lines in the top plan view on top of my light fixture, so that becomes a hybrid. After you create the symbol, you can go back and edit the line work or the geometry, and it will update throughout the model automatically. With this step-by-step process, I was able to do some other light fixtures to go with it and create a couple of fixtures that vary in geometry that I could use as resources. So now to create some drawings from this model. I first created sheets and then created viewports of the light fixture, like in top plan view, elevation, section, and an elevation of the vertical piece itself. Each viewport has dimensions and notes drawn in the annotations of each viewport, and in the object info palette, there are settings you can change, like the background render, to hidden line, shaded, wireframe, or other render modes. For each viewport, there are also settings that can be adjusted in the object info palette, like scale, viewport crop, drawing title and number, layer and class visibilities, and so on. Also, you can create a viewport style, so that each viewport will automatically take on the style settings and you don't need to edit viewports over and over again. This saves you so much time and helps you with organization. On the subject of rendering, these light fixtures look so cool when using the shaded view in Vectorworks. I placed all of the light fixtures in a certain staggered fashion and extruded a black semicircle for a background. Remember how I mentioned the glow texture for the filament in each light bulb? That texture has a glow setting, and I made it extremely large. You can edit textures directly in the Resource Manager. That makes the filament look really, really bright. Also, within each light bulb fixture, I placed a point light in the bulb and gave it a warm, light yellow color. Since I did that to the symbol, all instances where that bulb is placed is updated. With the point lights on, the shadows from each light look really prominent. To make the view pop even more, Vectorworks had shaded render view options where you can enable shadows, environment lighting, environment reflections, and so on. Also, there is a camera options tab where you can enable and edit depth of field, exposure, f-stop, and bloom, which is really neat because this is real-world camera settings. In this case, exposure is enabled and bloom is enabled as well. Bloom helps enhance extremely bright light, like the glow texture in the filaments. This is all in the shaded render mode, which renders instantly. From this view, you can create a viewport to show up on a sheet so that you have this view in your drawing set. There are other render modes than shaded, where the image can look more realistic or not, based on your settings. These views were using Vectorworks' in-house render engine called RenderWorks. This mode has similar settings and takes only a couple of minutes to render, depending on the quality settings or the DPI of the sheet layer, but the results are amazing. And that's how you do it. Vectorworks Fundamentals is a great software for 3D modeling objects, creating drawings from that model, and then also rendering it to make it look amazing.
Hi everyone, my name is Tony Kostreski. I'm a Senior Landscape Product Specialist at Vectorworks, and I am thrilled to be here today to show you how you can model this sculpture shade structure in Vectorworks Fundamentals through NURBS modeling. The tools and commands that I'm going to cover include NURBS curves, NURBS surfaces, surface array objects, extrude, and extrude along path. Now let's quickly go over some of these terms. First, NURBS curves are mathematical representations of smooth, continuous curves. I want you to think about garden hoses or flexible rulers if you've ever used one. You can bend it into any shape you want, but it will always be smooth and continuous. They are made up of a series of control points, and you can move those control points to change the shape of the curve. We'll dive into that in just a moment. NURB surfaces, on the other hand, are mathematical representations of smooth, continuous surfaces. So I want you to think about balloons. You can inflate the balloon into any shape, but it will always be smooth and continuous. The surface of the balloon will be the NURBS surface. Now in Vectorworks, there are two methods of drawing a NURBS curve. You can draw using the control point mode, which will have the curve pass between the vertex points or control points. Adjusting the control points with the reshape tool will adjust the overall shape of the curve. The other mode is interpolation point mode, which will have the curve pass through the interpolation points or clicks and interpolate the location of the control points that usually lies beyond the curve. You can still adjust this using the reshape tool. There are two additional factors that affect a NURBS curve: a degree value and weighted control points or vertices. The degree determines how many points affect the curve. The default is 3, but can be adjusted before drawing a NURBS curve using the curve degree setting. The lower the number, the closer to the control points, and higher the number, the flatter the curve becomes. A degree of 1, for instance, would create a straight line like a polyline. Now, it's important to note that the degree of NURBS curve cannot be reduced after it has been created, so it's important to choose the correct degree before you start modeling. Now, each control point on a NURBS curve has something called weight. We can almost think of weight as a kind of gravity. If the weight is increased on a particular point, the curve is pulled towards it, and if the weight is decreased on one specific point, the curve is pushed away from it. The default is 1, so anything above 1 pulls the curve towards it, like we see with the teal NURBS curve, and anything less than 1 pushes it away from it, like we see with the orange NURBS curve, which is set to 0.5. Each control point or vertex has an x, y, and z value, so if we switch to an isometric view, we can move the control points along any of the axes using the 3D dragger represented with green, red, and blue arrows. So let's move on to NURBS surfaces. There are many ways to generate a surface, but let's go over one of my favorites, the loft tool. This allows you to generate a surface in between two or more NURBS curves, or by using a rail and profile using some of the other modes. Once the NURBS surface is created, you'll see additional control points along the surface represented with U and V values. These are similar to X and Y, but along the surface itself. You can increase the number of control points by increasing the degree for U and V via the Object Info palette. Once this is done, you can either move the control points individually with the dragger using the first mode, or if we switch to one of the other modes, you can move all of the U vertices all at once by just selecting one vertex, like we see here, selecting this corner one, or this back one. Or we can switch to the V, which will do the same thing, but move all of the V vertices along that all in one go. So really it's not that much different than manipulating a NURBS curve or just manipulating an entire surface. For this last one, let's go over surface array. Essentially what this does is it grabs an object like we see here with this teal, and it duplicates it across a surface. In this case, we have a NURBS surface. So if we select Create Surface Array, we can have it repeat along the x-axis a certain number of times or by distance, and same with the y. We can choose to display the base surface or not. We can always make modifications afterwards. And we can also, instead of number of repetitions, we can select a very fixed distance. So in this case, they're both repeating every 5 feet, so we get a perfect square repeating along this. You can also adjust the y and x factor. So if we do 0.5, then we see that each one is offset half its shape. So let's move on. All right, let's go ahead and create the sculpture shade structure. I'm going to activate the NURBS curve and we'll draw a 20-foot NURBS curve. I'll just make a copy of it and move it in the Z direction 8 feet. We can then use the loft tool and the no rail mode. We can select both NURBS curves. We can preview it. We can keep the curves. In this case, I'm not going to keep the curves. And if we double click it, we can immediately see the control points. There's only 4, so this isn't going to be enough detail. So what we can do is increase the degree for both the U and V. And in this case, I'm actually going to do 6 for the V. And then we can move the individual control points. Now, if you shift click, you can move multiple. I'm going to move these out 4 feet. Next, I'm going to select the V vertices mode, and we're going to scale. So again, the V are going to be all the ones that are vertical, at least in this scene. And then U is going to be the ones that are more horizontal. So if we shift click these bottom 3, we can scale this. And I'm just going to type in 1/3 or 0.33 just to scale that. Next, I want to rotate this top one. So that's going to be the U vertices. And we can use this first mode again. Now, if I do it from the edge, you can see that I can rotate the entire U, but I actually want to move this inward a little bit. So I can click this control point and use this third mode to reposition it. I'm going to move this 4 feet, and this will be my point of pivot. We can switch back to the translate rotate mode, and I'm going to type in 25 degrees for this angle. This next part, I think it's easier to do this in orthogonal view, where we can tap on the number pad to view this from all different angles. Now, from a front view, I want these all to be aligned. So I'm going to go ahead and move those now. Now you can certainly do this in multi-view and jump between the different views, but I'm just going to stick to one view for now. So I'm going to switch this to just the single vertex point, and I'm going to adjust these so that they all line up to get the shape that I want. Just a few more. Two more, last one. Okay, and then let's switch views. From this side, I also want this to line up as well. Let's go back to an axon. And just to have more interest shape, I want the bottom to look more like an S. I can move this out a little bit. Let's go maybe a foot. And then I want this top part to open up more. So I'm going to grab this one and move this back. Let's go 12 feet. Now that's the shape I am looking for. So next, let's go ahead and create a surface array. And I'll switch back to a normal perspective view. Now you can use any of the listed array objects to create a surface array, but let's start off with just a simple rectangle. I'm just going to type in 4 inches and 4 inches, and I'll just place this anywhere in my drawing. We can select both objects, go to Model, Create Surface Array, and I'm just going to type in 10 for both. 1, you can display the base surface or not. We'll see what that looks like. So we have 10 going in both the U direction and the V direction, or X and Y. I can turn off the base surface. Let's increase this to 20. Now the issue with using a rectangle is we're going to have these openings that we see here because they're just planar objects trying to wrap around a curve. So if we go back in here, we can always go back to the array items and we can adjust this. Let's see what happens if we extrude this 4 inches. So essentially we just have a cube. If we close out of there, we see that we actually get depth between all of these, which looks pretty neat. There's some fun things you can do, like shift the offset. So if we do 0.5, for instance, you get like this brick effect, like a running bond effect, which is pretty neat. But this isn't really what we're going for. If we want the 4-inch post that we were seeing, we can change number of repetitions to a fixed distance and actually type in 4 inches. Give that a second to process. You see it's actually creating quite a few of them. And if I want a gap and the gap to also be 4 inches, I can do a factor of 2. Now this is getting close to what I want, but you see that it's got these openings here and it's not necessarily what I want. So we can think about other objects that might work here. Now if I change this to 1, you'll see that that extruded object is just going to make all these straight objects. So what can we do to make these actually curve? So we can go back in here, go to array items. Let's go ahead and delete that. And I'm going to draw just a simple line. We'll just make it 12 feet. And we can convert this to a NURBS curve. So let's go ahead and convert that to a NURBS and close out of here. It's still straight lines, but remember we can adjust the degree. So let's go back here. Right now there's just 1 degree, so it's just 2 vertices. We can go to 6, for instance, which will start giving that curve. We could even go as high as 24, and we start getting some really nice curves here. So what can we use to get the shape we want? We could actually use extrude along path. So instead of doing that individually on each of these, let's go back here, and we can draw that square again, or rectangle, and run the extrude along path. So the array item is going to look like just a regular extruded rectangle, but it's extrude along path, and the path has a number of degrees, which allows it to bend quite easily. So if we close out of here, we get the shape we want. Next is going to be the bench. Now you can draw this with either the polyline tool or NURBS curves to generate a NURBS surface. In this instance, I set it to an elevation of 18 inches. And I'm just going to go ahead and group this so that we can focus on just this element here. So again, this is a NURBS surface, and we can do a couple things with it. We could use the push pull and give it some thickness. So I'm just going to give it a thickness of 2 inches. And we can also extract the side. So even on curves, you can use the push pull. So I'm going to add 18 inches to this as well, so that we have some seating here and just a nice little extension on this end. If we wanted to make this curved, we can add a fillet edge to this. So I'm just going to do 1 inch. And then last, we can apply a texture to it. And in this case, I'm going to change the map type to auto align so that it follows the curve. And then we can click out of there, and then ultimately we can start adding additional elements, maybe add flooring, apply different textures to the sculpture. In this case, I'm using a metal that's reflective. I wanted to see how the space felt underneath, so I added entourage elements. And then of course, because it is a shade sculpture, I added a light source object using the directional mode, which allows me to play around with the light and see how it interacts with the sculpture itself and see what kind of shadows are cast by that. Now, the last thing I want to leave you with is, even though this is a surface array object, it is using those extrude along path objects. We can actually explode this, if you will, or ungroup it by going to modify, ungroup, simply select yes, and we actually now have 61 individual extrude along path objects. This is fantastic if you wanted to fine tune any of these for whatever reason, if you wanted to delete them, or we could go into the reshape tool and we can start fine tuning any of these if that's something you wanted to do. So that's the sculpture shade structure. I hope you're able to take these methodologies of NURBS curves, NURBS surfaces, surface array objects, everything that we went over today. You can take these and apply them to a variety of different objects in product design, furniture design, you name it. NURBS modeling is a fantastic method, especially when working with curved shapes. So appreciate you all coming today. And with that, I'll pass it along. Thank you again.